My name is Sebastian, and today we'll be calculating truss forces. Here is our problem right here. Our methods, or our members will be AB, BD, DC, AD, and AC. We cut it. That this is statically determinate, we have this problem 2J, which is the number of joints, A, B, C, D, which is 4, and equals to M plus R, which is our members for M, which is AB, BD, DC, AC, and AD, which is 5. Then we have our reaction forces, which is 3, because C is a roller force, meaning it's 1 reaction force, and D is a pin force, meaning it's 2 reaction forces. So 8 equals 8, showing how it's statically determinate.
Alright, so we're looking for RCY, and to start, we're going to do 2 feet times RCY plus 500 pounds times 2 feet. And so when we do that, the first thing you want to do is actually to multiply 500 pounds times 2 feet, and you get 1,000 pound force. And the next step would actually be to minus that 1,000 pound force and put it on the other side, and then we easily can just simplify and do 2. We can just divide the 2 out, and we can get a nice RCY equals negative 500 pounds. Alright, so we just solved for RCY, so now we're just going to get rid of all the forces in the y direction. So here we're looking for forces in the y direction, but first we're just going to get the forces in the x direction. So we know we don't have really any forces in the x direction, and this is a principle, so we're going 2 ways. So RDX is equal to 0, and RCY and RDY is the y direction. We obviously already know that RCY is equal to negative 500 pounds. So if we plug that in, we make this equal 0 using the zero product property, then we're just going to add 500 on both sides, leaving RDY to equal 500 pounds.
The first joint we want to solve the members for is C, since we already have our CY. Going in compression, which is 500 pounds. So to find the other things going in the y direction, we do some of the forces in the y direction, which would be RCY plus AC, because AC is going up or down. We don't know that yet. Equals 0. And since we have RCY, we have negative 500 pounds plus AC equals 0. Add the 500 pounds on both sides, you get AC equals 500 pounds in tension, meaning that this goes out instead of pushing into C. And then for the forces in the x direction for C, since we only have CD equals 0, it'd just be tension, and there wouldn't really be going anywhere since it's 0, but it'd still be pushing out since it's positive. Alright, so the next members to find would be AB, AD, since we're doing the joint A, because that is the easiest one to do after C, because we already have AC. So let's do the sum of the forces in the y direction, which is equal to 0. It'd be 500 pounds, since the 500 pounds we have here, plus AC, which is also 500 pounds, plus ADY. ADY would just be AD times sine of 45, since these angles are 45 degrees, and it's a 45, 45, 90 triangle for both. So it'd be 1,000 pounds plus 80 times sine of 45 equals 0. You'd want to move the 1,000 pounds to the other side, so you subtract 1,000 pounds from both sides, and you get 80 times sine of 45 equals to 1,000 pounds. And then you want to divide it by sine of 45 on both sides, which gives you AD equals to negative 1,414.21 pounds, which is in compression. Now, we gotta find the forces in the x direction for A, since I had no space earlier. Sum of the forces in the x direction equals 0. AB plus ADX would be 0. AB we don't have, but we do have the ADX, which would be AD times cosine of 45, which would be negative 1,414.21 pounds times cosine of 45, which would be negative 1,000 pounds, plus AD equals 0. So you want to move the 1,000 pounds to the other side, which gives you AD equals 1,000 pounds in tension. Yeah, right.
So the forces in the x direction, we already have that, so we're just going to disregard that, of course. And for the forces in the y direction, we already know RDY is 500 and ADY is negative 1,000. So what we're gonna do here is we're gonna add 1,000 to the other side. We're gonna take this 500 and subtract it, and that will leave us with DB equals 500 pounds in tension.
So here we have our force diagrams, which shows A here going attention to AB, 500 pounds, since coming out, instead of pushing in like AD, since in compression which is negative 14.21 pounds. Same thing for AC, in tension, 500 pounds. Same thing for C, 500 pounds. Then from C to D, since it's 0 pounds, which is positive, it go in tension, so it's coming out. Same thing for D. And then for AD, it's pushing into D because it's compression. And then for DB, it'd be 1,000 pounds, so they're pushing out instead of in, since it's tension. And then for B and A, it'd be 500 pounds. And then here are all of the problems and answers. And yeah, thank you for watching.